Hi, I'm Soulsworn, and this is going to be a terrible video on why Star Citizen's flight systems just don't work. Their flight model is not successful, it can't be, and their design philosophy is flawed. Unrestricted spaceflight is unhealthy for the game, and it's not really possible to work. So let's start. So let's say we have a ship here, and we have a ship here. We're going to call them Ship 1, Ship 2. And let's say that we have Ship Two's weapons cone and sight cone, just kind of labeled out here, right? And it's not going to be exact. If Ship 1 cannot exit the sight cone of Ship 2, then the only thing that can happen is an aim duel where they're just kind of wiggling around in space and shooting at each other. It's very arcadey gameplay. It's not fun. It's not rewarding. So what Ship 1 needs to be able to do is Ship 1 first needs to be able to close distance. And what that does is it shortens the distance that Ship 1 needs to move to exit the sight cone of Ship 2. If we compare, the distance here to the distance back here, we can see that one line is significantly longer than the other, right? So as we close distance, we lessen the amount of distance we have to take to exit their sight cone as well. Our movement is more significant from their visual perspective. Now, let's talk about why we can't do this, why we can't effectively close distance in Star Citizen. So let's say we have two ships again. So we have Ship 1 and we have Ship 2. And let's say they have perfectly circular acceleration profiles, perfect circles, right? And so we have them like this and like that. And let's say they're the exact same. So can Ship 1 catch Ship 2? If Ship 1 flies at its maximum acceleration towards Ship 2, who's flying away at his maximum acceleration, and we have lines A, and we have lines B, and A equals B, then clearly Ship 1 can never catch Ship 2. This is further confounded by the fact that if Ship 2 just creates a random vector, Ship 1 has to react, it's reactionary, in creating a pursuit vector, which means that Ship 1 can never be as efficient in creating pursuit vectors as Ship 2 can be, and just creating random escape vectors to go away. So no, Ship 1 cannot catch Ship 2. So let's try a system on like a acceleration profile on the opposite end of the spectrum, which is more restrictive. So let's say these ships can only go forward towards each other. So they can only accelerate forward. Can Ship 1 catch Ship 2? The answer is no. Here's why. It's kind of a two-part question, or kind of a two-part answer. So we can have a configuration where Ship 1 is facing the same direction as Ship 2, and Ship 2 simply flies away, right? We end up in another situation. We have lines A and line B, and A equals B. Therefore, Ship 1 cannot catch Ship 2, and Ship 1 is once again reactionary in its ability to create pursuit vectors, and therefore less efficient. It's going to have to use more resources like boost to attempt to close distance, and it just never will catch them. But what if the ships face the same direction? Well, then one situation that can happen is they just joust through. We add these two lines together, and the ships just fly past each other because they can't cancel out their vectors. But what happens if they stay nose to nose and they constantly stay on target? Well, then an orbit will occur. So the two ships will orbit around an invisible point between them. So we have Ship 1 and Ship 2. And after a certain amount of time, Ship 2 will orbit around and still be trying to keep nose on to Ship 1, who will end up over here. And what happens during an orbit when you're using forward throttle is something called tangential acceleration. So as a ship is moving its nose to track a target, and it's using forward throttle, the inputs look like this, the vectors you're creating for your acceleration. And if you keep following that around a circle, so let's go ahead and map that out around a full circle. And let's say you're attempting to get to, keep your nose on a target in the center. You will notice that all of your tangential acceleration inputs start to look like this. And do you see that any of those green arrows take you closer to that red dot? None of those arrows are pointing inwards, so the answer is no. And then if we map the vectors that each of these ships can create from the starting point, and then after X amount of time, you just keep drawing arrows, and there's infinite arrows here essentially. And then we map the ones on this side that they are actually additive and none of them cancel each other out. Therefore, you can't really cancel out the vector of another ship, so you're either forced to joust or stay in an orbit. What this ship would need to do is create this vector. So if Ship 1 wanted to, after X amount of time, if it wanted to intercept Ship 2 here, it needs to be able to create that vector. We've already talked about in this situation, it can't because it can only go forward. So what we've proven is that from a acceleration profile that's perfectly round and universal to one that is very restrictive and forward and everything in between, you cannot eliminate escape vectors with acceleration profile. And why that's important is if you can't get close enough to exit a sight cone, you can only have arcadey, like hot air balloon pistol duel gameplay, and it's terrible, right? So let's quickly talk about how Master Mode made this way worse. Master Mode's made this so much worse. So let's say we have two ships and they're in an orbit, right? And this ship is going after X amount of time to go there. And so this is ship 2, and let's say it's ship 1. And so let's say we had the old acceleration profile, which was a cuboid, right? So if he wants to try and close distance on ship 2, he needs to take a pursuit angle. And this generally lines up reasonably well with the trichord, right? What Master Modes did is it shaved this all down. See how how we're losing this whole blue area right here of really important vectors that allow us to close distance in an orbit and make good moves? Yeah, Master Modes took that away, which made the game feel a lot more arcadey, but it didn't stop there because it has other effects. So once again, if we draw that same diagram we started with the sight cones, and we're wanting to exit this cone of vision, the most efficient route is perpendicular as far as distance is concerned, but the most realistic route is going to be one that takes you closer while exiting, as well as being on your greatest acceleration angle. So, something like your trichord from the previous flight model, right? And once again, Master Modes nerfed that, whatever. It looks more like that, but you get the idea. And so we lost this whole, in this case, we're going to make it a, I don't know, run out of colors here. It's going to be yellow. We lost this whole, good God, look, seeing that. We lost this whole yellow zone of angles we could take and extra acceleration on those angles, rather. And so it made it more difficult to exit the cone of vision. But that's not the only issues as to why you need to be able to close distance. Let's talk about some other things you can abuse if you know your opponent can't really close distance. So let's say we have two ships again. And one is going to be flying away at 300 meters per second. And we'll call this ship 2. And ship 1 is going to be pursuing at 300 meters per second along a pursuit angle, right? So if we do the math on the gunnery system, let's say they're both firing weapons that travel at 600 meters per second. For ship 1, we subtract the speed of the opposing ship because it's moving away. And so that gives you an effective weapons velocity of 300 meters per second. But for the other ship, we add ship 1's velocity because it's trying to close in. So 600 plus 300 equals 900 meters per second. It is dealing with 3 times the effective weapons velocity of the ship that's attempting to pursue it. What that means is that the ship 2 has a very, very small pip displacement to deal with. It's very predictable because ship 1's taking a pursuit angle, and it's just very, very accurate pip. Ship 1 is firing at a very inaccurate pip that is experiencing 3 times the pip displacement roughly. And so it's going to have a lot of inaccuracy to contend with and just general issues with pip calculation and the gunnery system screwing it over. Here's another problem. Convergence. So if we have a ship down here, we're calling this ship 1, and we have ship 2 here, and we're flying a Gladius. Since we look at the convergence profile, we have a nose gun, and then we have the 2 side guns, and they're going to converge right before the ship to try and make, increase your odds of hitting it, right? But what happens if ship 2 flies away while you're fighting, or while you're firing, rather? It ends up back here. Well, these 2 lasers are pretty much forced to miss. Weird, huh? So now ship 1 can only do 1/3 of its DPS. It's hugely problematic. There's a lot of issues with Star Citizen's flight model. They all benefit the kiter. The kiter has to use less resources. We talked about how pursuit angles are inefficient. The pursuer has to use more boost to catch than a pursuer has to use to flee. We talked about how the gunnery system, because it doesn't inherit velocity of the ships, how it favors kiting, and how convergence will just always favor kiting due to the nature of convergence. They have to somehow change things to motivate players to close distance and engage in combat. And they just haven't even remotely addressed this problem as of yet.